Hi, hello everyone, and welcome back to my YouTube channel Spotify Learn. Today I'm here with the next module video of that is operating system module 4 video. Let's start without further wasting time. If you're watching my channel without subscribing to my channel, please do subscribe and then watch my videos. And let's start with it. Okay, now see what is TLB. Explain TLB in detail with the paging system with a neat diagram. They have asked first what is TLB. First you look for what is the full form of it. Translation, look aside, buffer. Okay, now the standard solution to this problem is to use a small fast lookup hardware cache called a TLB. Okay, as you know the full form TLB, I'll be spelling. It is what associative high speed memory. Each entry in the TLB consists of two parts, that is a key and a value. Next is you can see when the associative memory is presented with an item, the item is compared with all keys. Okay, it is compared with all keys. Now in the page if the page number is found, it is frame number is immediately available and is used to access memory. Now the whole task may take less than 10%. Less than 10% long it would have taken for unmapped memory references were used. Okay. Now, if you understand the diagram, first there will be a physical memory. This is the page table. This is the page number. This is a frame number. This is the CPU which is connected. And there will be logical addresses, that is P and D. And you will have page numbers and TLB hit will be there. F and D will be there. That is a physical addresses and a physical memory. It will be connected. Now, if you see the advantage and disadvantage, search operation is fast. Hardware is expensive. Now next you can see some TLBs have weird down entries that cannot be removed. Now you can see next question is about the I'll more explain about the numerical so that it will be clear perfectly for you. This I'll also be explaining about this also theory part but not much. Okay, with knee diagram explain the various steps of address binding. Okay, what they have asked is about the address binding. Okay, now what are the steps means first is compile time, now load time and execution time. Remember it as CLE. Okay, CLE. Now you can see the diagram. There will be first source program. It will be going to object module, load module. Okay, in that what compiler or assembler will be there, that is compile time. Linkage editor and loader will be there, that is in the load time. And in memory binary image, okay, that is the execution time. It will execute. Okay, next that is the step processing of a use, that is address binding. Now you can see the third question is about the demand paging. Explain the steps. Okay, now if you see what is demand page, it's similar to a paging system with swapping. Swapping means what? If you have 0 1 you will do 1 0, that is basically swapping. Okay, I hope you got this. Next is we want to execute a process, we swap the process into memory, otherwise it will not be loaded into the memory. Now what are those you will do? Bring a page, it will need less input output, less memory needed, fast response, more user, page is needed in order for reference, invalid reference, not in memory, lazy swapper, swapper that deals with pages in a pager. Okay, is a pager. Now what are the steps that you will do? The memory address will be there, no, that will be requested. It is first checked. Okay, it will be first checked to make sure that it is a valid memory request. First what the request will be given, it will be first checked whether to check it as a valid or not. Now next what you will do in order to see if the reference is an invalid, that process is hold terminated. Terminated means what? It will be deleted. Next you can see if the page is not present in memory, it must be paged in. If it is not present in the memory, if this is a memory, if it is not present, you have to page it in. Okay, I hope you got this. You have to what? Page it in. Next you can see a frame is located possibly from a free frame list. Next disk operation, then you will be loading into the memory and you will get a free, that is new frame number, and invalid byte is changed to indicate that it is a valid page reference. Now let's discuss about the diagram. Ee diagram alli first ನಾವು ಏನೋ ಒಂದನ್ನು ಲೋಡ್ ಮಾಡ್ತೀವಿ. ಈ ಲೋಡ್ ಮಾಡಿದಾಗ ಈ ಪೇಜ್ ಟೇಬಲ್ಲು ರೀಸೆಟ್ ಪೇಜ್ ಟೇಬಲ್ ಇರುತ್ತೆ, ಫಿಸಿಕಲ್ ಮೆಮರಿ, ವಾಟ್ ಆರ್ ದ ವಿ ವಿಲ್ ಡಿಸ್ಕಸ್ ಇಟ್ ಸ್ಟೆಪ್ ವೈಸ್ ಏನಾಗುತ್ತೆ, ಫಸ್ಟು ರೆಫರೆನ್ಸಿಗೆ ಹೋಗುತ್ತೆ. ಈ ರೆಫರೆನ್ಸಿಂದ ಏನಾಗುತ್ತೆ, ಟ್ರ್ಯಾಪ್ ಸ್ಟೇಟಿಗೆ ಹೋಗಿ ಏನಾಗುತ್ತೆ, ಪೇಜಸ್ ಆನ್ ಇಟ್ಸ್ ಬ್ಯಾಕಿಂಗ್ ಸ್ಟೋರಿಗೆ ಬಂದು ಮತ್ತೆ ಇಟ್ ವಿಲ್ ಬ್ರಿಂಗ್ ಇನ್ ಇಟ್ಸ್ ಮಿಸ್ಸಿಂಗ್ ಪೇಜ್. Next, the physical memory will be there. Next, it will reset it and it will restart. Okay, this is basically the steps in a page fault. You should diagram, you should be perfect so that you can explain theory in your own words. Okay, a page fault, what are the sequence means? First, it will trap, save, determine, check whether it is request, and issue a read, wait for the device. This is wait in a queue for the device, request is service, then you will begin. Next, what you will do while waiting, allocate the CPU to some other user, because CPU will be what engaged. Now next question is about the what is segmentation. Okay, the definition you can go through it. What is the basic method is, each segment has a name and a length. Okay, each was what has it a name and a length. Okay, now the address specify both segment name and offset within the segment. Next, what you have means, normally the user program is compiled and the compiler automatically constructs segment reflecting input, that is the code, maybe global variables, the heap from which memory is located, and standard C library and all. Now if you see this diagram, there is a subroutine, stack, symbol table, main program, and a square root. This is for the logical address. Okay, now next is segmentation, is a what memory management scheme that supports this user view of memory, and the user therefore specify each address's name, segment name, and an offset, and which is partitioned and all. You will have segment number and the offset, as you know. And what are the compiler might separate from the following means, the code, global variables, heap, stack, and the standard C library, which you already saw. Now next question what they have given is about the discuss the structure of the page table with a suitable diagram. There will be having three techniques: hierarchical, hashed, and inverted. Let's discuss all the three. Hierarchical means what, in some order. Okay, now what is the problem means, most computers support a large logical address space, that is 232 to 264 in the system. The page itself become excessively large. What is the solution means, you divide that into, if you have one big problem means, you have to divide that into smaller problems. That is the basic idea here. Okay, I hope you understood about this. Next, you can see there is one outer page table. They are divided into smaller sub pieces. Okay, that is two level paging. For example, consider the system with 32-bit logical address of 4 KB. You will have 20 and 12. Okay, and next you can divide that 20 again still into 10 and 10. That is how you will show 12, 10 and 10. This is for what, 32-bit address. Okay, now next is hashed means what, there will be one address. Okay, hash value, it is the virtual page number. Okay, virtual page number will be there, value of that mapped will be there, pointer to the next element in the list will be there. The algorithm which works is, first was virtual page number which is there here, you can see here, that is into the hash table. Next, virtual page number is compared with the first element, again it is compared. Next, if there is a match, that it is desired physical address. If there is no match, subsequent address entries in the linked list are searched for a matching virtual page number. See, there is a logical address and the physical address. As you know, this is the hash table. Hash function will be performed and then it will be divided into P. See here, PDR, PDRD is there. Now what it became, QS and PR. Okay, PR has been remained as it is. Next, you can see inverted means what, doing it reverse, has one entry for each, and it consists of real memory location and information about the that owns the page. It has a virtual address and the inverted is a pair. Okay, you can see this diagram. Next comes the important question of this module is about the, you have to do the FIFO optimal LRU. Okay, let's see what is FIFO. FIFO means, as you know, first in first out. Okay, now write down the reference string which you which you have already got. Okay, 6 2 1, it is missed. Okay, now what you want to do is, first let's understand what is FIFO. And they have mentioned here what, 3 frames, so you need to divide it into 1 2. Okay, let me show here, 1 2 and 3. You are dividing it into 3 frames here, as you can observe. So now write down the first string, write down the second string below it, write down the third string below it. Again, next step what you need to do, you have to compare the string with here. Okay, 1 ಇದೆ ಅಲ್ಲ ಇಲ್ಲಿ, ಇಲ್ಲಿ 1 ಇದೆಯಾ? Yes, ಇಲ್ಲಿ ಇದೆ. So again this only you will keep it as it is. ಮತ್ತೆ ಇಲ್ಲಿ 0 ಇದೆ, 0 ಇಲ್ಲಿದೆ, it is repeated, this element is being repeated in the string. Okay, now you will keep it again as it is. ಮತ್ತೆ ಇವಾಗ ಏನು ಬಂತು, 2 ಬಂತು, 2 is not present here. But in this FIFO algorithm, what you will follow means, what is first in will be there, no, that only you will make it first out. Okay, that means see, 1 is from here, 0 is from here, and 7 is from here. Okay, now you can see this is first in, right? So you will make it as 2 here. Next 0 7 will be as it is. 1 is not present here. See, 2 is from here, and you can see 0 is from here only again, and 7 is from here, which is this 0. So you will replace 0 with 1 here, and 7 you will replace again. 2 is repeated, so 2 1 7 you will keep it as it is. 3 is not present, 7 is been repeated from here, so you will replace this again. 0 0 is not present here, which is repeated most, 2 2 is repeated from here, you will replace 0 1 3, and again 0 1 3 will be there, 2 is not there, we will replace 1 from here, it is repeated, so 2 3 you will keep it as it is. Next again 4, the same way you will replace with first in first out, which is last element which is coming, like more times which have repeated, you have to do that. What is this yes no? Y means it is yes, n means it is no. Okay, let's understand what it is. Yes means it is a miss type. Okay, miss. And no means it is hit. Okay, what is miss and hit? Let's understand. 1 is there, you will give a miss. 1 again, it will be a miss. 1, it will see 107, it will be a miss again. 107, this is again repeated here, this is there, it's 1 is already here, it is repeated, so it is a hit. Again 0 is here, it is a hit. Again here what you can see, 2 is in the previous step, so it is a hit. Again here you can see 3 is in the previous step, so it is a hit. Again you can see 0 is in here, it is a hit. You can see 5 hits are there, 13 non-hits, that is yes elements are there, that is miss. Okay, now you will calculate the total number of page faults will be how many numbers of s are there, and you will calculate if you want the accuracy, because they have asked which algorithm is more efficient. Okay, you will calculate by 5 by 18, that is hit ratio. You will get it as 27%. Okay, now next if you see this optimal, again the steps are same. 1 you will write 10 107, you will write 1 is repeated, 107 you will write, 0 is repeated, 107 you will write. Here 2 is not repeated, and this what you will do, see, optimal means the same way. See, first I hope you got these steps. What are the steps that you have to carry is, I hope you are getting, replace that one will be not used in the future longest. See, what does that means? I'll write it because you will not understand. Not be used in future. Okay, which is not being used. See, here you will see 1 is being used, 0 is being used, 7 is nowhere, so you can replace 7 with 2. Again 1 is repeated, you will write, 2 is repeated, you will write again, 3 is not repeated, you will see for 1 is at the last, 0 is here, and 2 is here, 1 is at the last, right? So you will replace 1 with 3, 3 0 2, you will see 0 3 2, 2 you will replace again, and no, sorry, 3 is repeated, right? So 302, again 2 is repeated, 302. To replace 4, what you will see, 302, 0 3 2, 2 you will replace with 4, again 0 304, again 3 304, 6, right? You will replace what, 3 is never used. Okay, 3, see here what you can see, 304, no is future, it will be used, so you can replace first only if you like. And next is again, and 604 nothing, you can replace 1, and 1 nothing, 104, that is again again the hit and miss ratio will be same again. Next you can see here Again miss. Okay, it will be hit because it is present. It will be a hit because it is present in the previous. Next you can see here it will be a hit because one is present in the previous, and you can see which is repeated, right? This will be a miss because 2 is not present here. 1 is present, 2 is present, and 3 is not present, so it will be a miss here. What is 3 is not present, the previous elements will be seeing like that only. And again total number of miss will be what, 9, and hit will be 9, again it will be 50%. Now next is about the last recently used. See again 110 107. Now what you have to replace means again the same techniques. If it is same, it's fine. Which is least recently used? 107 107. Okay, now 102. Why? Because you replaced 2 with here. See here 107. There what you did in FIFO, first in first out you did. Here what you need to do, least means this, right? You use this recently, so you'll replace 7 with 2. 1 again repeat, 2 again repeat, this will be a hit. Again 3, it's not there. See 1 is from here, 0 is from here, and 2 is from here. And see, you can see here 2 was the, see first is 1 1 again it will be a hit, 0 it will be a hit, and next is 2, you will replace 7, and next you can see 1, right? 1 again it will be a 102, 2 it will be 102, 3 is not present. So in order to see, 1 is from here and 0 is from here, so you will replace what, 3. Okay, 3, that is last recently used. Now again 0 you will replace, that is 1 will be replaced. Okay, next is 0, again you will keep it as it is. You will replace 1 0 3 2 0 3 2 0 3 2, and 4 you want to replace means 3, this is here it is used, right? 0, that is you will replace it with 0. Next is about 0, again it will be repeated. 3, in order to repeat 3, see here you can replace here 3, and again the same steps you need to follow where it is last recently used. You will get it as page faults will be equal to 1 2 3 4 5 6 7 8 9 10 11 12. Okay, it is 12. Okay, sorry, I have written as 6, it is 12. Okay, now this will be 33%, which was more. There you got as 27 for FIFO, you got for LRU it is 33. More you got as efficiency is optimal, that is 50%. So which is most best is optimal. Optimal is best algorithm. This is about the fourth module. Next, tomorrow I'll be uploading the fifth last module of the OS. Thank you for watching the full video. Make sure to like, share, comment and subscribe to my YouTube channel if you're watching without subscribing. If you want the same PDF, you can DM me on Instagram. The Instagram account will be provided in the description box. Thank you for watching the full video. Meet you on the next video. Until then, stay tuned.